of the doors to have an easy walk. So I'll make reference to the original drawing as I go on.
Since what I did that day was on my own project, or on the project we are both working on. I copied the file on the workspace. I copied it to one place. So you have the original file and the one you'll be working on. Perhaps sometimes I keep the original file that I get from the architect. I keep it separate. So I create my own, so I can do anything I want on it. So I can always go back to the one I received from the architect.
Okay.
So that would be like a backup.
Okay.
So you can do whatever you feel is convenient for you so far on the when you are working rather.
Okay.
All right.
All right.
So good. Before we proceed, I would like to have a brief recap of what we did last week.
Okay.
So basically, what we did, the first thing we did yesterday was we try and explain to ourselves the aim and objective of the course, what we are going to be talking on, and what are the core objective of the project as per what the boot camp is even all about. Then we talked about structural design requirements, where we talked about safety, serviceability, durability, and reliability. So we made mention that these are like checks that we use in certifying if a structural design is really right or not. Then also we talked about the design limit state, where we talked about the ultimate limit state and the serviceability limit states. The ultimate state, the maximum load at which the building collapse or the structure. Let me put it that way: the structure collapse. And the serviceability limit state is when it shows deformation and is as a result of probably an imperfection in one certain aspect of the design or the construction. Then we moved on to the classification of loads. We talked about live load, dead load, and accidental loads. Then later we talked about the load combination. We talked about the loading code, that's the 6399. Then I think I made mention of Eurocode too. Then I think I spoke about the advantages it has over VS Code. Then we talked about the live load, the expected live load of any structure, be it residential or let me just say, based on their function, the expected working life that we are expecting from there after a thoroughly certified design. Then at the tail end of the introduction, we talked about structural materials, where I talked about the concrete grade, what some of the factors that influence how you specify the concrete grade you specify during your design. Then I could remember vividly I talked about soil report, that's geotechnical report. So in relation to how you choose your concrete grade. Then I talked about reinforcement too. What are the classification and perhaps their uses to a certain extent. Okay, then we moved to preparation of GA, and we were able to reach certain extent that day, but unfortunately we were unable to finish, and we still have a long way to go as per the general arrangement preparation. And before we started, I explained the importance of having a very good general arrangement. What it does in terms of, I don't think I talked about the cost implication, but I talked about the function aspects, like keeping the function as being specified by the architect, and collaborating with other special experts that are involved in the project in order to have a holistic design. There won't be any clash whatsoever when the construction starts. I believe you remember all these things that we talked about.
Yeah, I'm aware of them all.
Okay, thank you so much. So on that note, I will share my screen now. Then we proceed from where we stopped. Can you see my screen now?
Yeah, I'm seeing it now.
Okay. Yeah, I clouded one place. I believe I clouded one place here.
You
Can
did
you see
what?
there is a cloud here, the cloud. I've selected the
Okay,
cloud.
yeah.
Can you tell me what the cloud represents? Like, what do you understand by that?
I can't really say, but it's like you're trying to highlight a particular portion to represent something significant.
Very good. Thank you so much for that point. That was where we stopped last week.
Mm.
So the reason why I did that is in design, when you are drafting, these are some of the things you do. You cloud places, significant places, probably a point where you think, okay, there is a detail that you will not want to miss here, but out of having a lot of details in the drawing, you think you might forget. So it's always good to cloud your drawing so you can have a reference. It will serve like a reference for you to have probably something, an overthought that came to that came to your mind while in the process of producing your drawing. You understand? So I will take this off since you have understood the importance now. So that was where we stopped last week.
Yeah.
Okay. Now let me take out the ground floor and the first floor that we have superimposed and see clearly where we stopped last week. 50,000. So last week we were able to do all this, and while doing this, we considered the aftermath. What I mean by aftermath is when we are done with this floor GA, what are the later things that might come in? And that was where we are talking about, okay, we can plant our column later on this, so the column can support the roof beam. Although we have not reached the preparation of roof GA, but then while preparing your GA, you must consider, okay, what is coming on later also. So while we're preparing this, we consider that when we're preparing where my cursor is currently, when we're preparing this, we considered beams that are going to support our planted columns, the planted columns that are going to resist the load of the roof beam. Then here as well, that was what we did. Then here we have staircase here. Then there is a beam we created lately that day. So let's take this back. Now, the red colors remains our beam. That's our beam outline. Then the green color denotes our ground floor, while the magenta color denotes our first floor. So now we continue from there. Now we have, what's it called here? We have void in this place. And the void is inclusive of the staircase. Mind you, our staircase is already an opening. So anywhere we see staircase is already a void. I think we have done something on that before we left last week. Let me check. Let me confirm again. 50,000. Yes, we've done something on that. So the whole of this contains both the void and the void for the staircase. So we have done justice to that already. Please let me know if you have any question as usual.
Just the way you move the walls, the floors on the already prepared work. I don't know what command you use there.
What I used to do is when I'm moving, if I want to move any of my drawing, I used to use a whole number. So if I want to take it back, I can easily move it back with that same whole number. So what I used to do is if I want to move, let's say if I want to check the previous drawing I've worked on now, I will move this old drawing by, let's say, 50,000 millimeters. You understand? So if I move it back by 50,000 millimeters, it's going to go back to the exact place where it was before.
Okay.
You understand?
I do.
So now we can extend this beam actually. This beam, we can say, let's take it all the way down here. You know, we have a beam here already that is going vertical, that is starting from here and it goes all the way to this place. Although we have not treated it, but we have a beam. We have a presumed beam there. So let's take this all the way to have this. Okay, is that okay? Then if that should be the case, that means we have the whole of this as a single slab, which is not too big enough, which is not too big rather. In terms of LX, the LX is 3.82, so it's still fine. So we can leave this like this with this beam. Then now we've created void, and we have a beam here, which is very good. So we can say this portion of the slab is like a cantilever, right? Is it really a cantilever?
The portion of the beam.
It's this area that my cursor is. Is this a cantilever?
Yes, it's a cantilever. Yes, it is.
It looks like a cantilever, but it's not a cantilever. Why? We have a beam here. We have another beam here. We have another beam here. So now, well, I can say it's a cantilever, and I can say it's not a cantilever.
Extension of the slab to the staircase there.
Yes.
But it's more like it's attached to the land, this thing, the final landing, I believe. If that's what it's called. Like when you move from down to up, the final landing where you're going to step on before the corridor to the staircase.
No, I'm coming. Let me show you something. Let me pick the first floor. Let me take it off. Now this is my ground floor.
Yeah.
The ground floor is telling me that if I'm on the ground, if I want to go up, I start from here. Can you see that?
Yeah.
So my final landing on the first floor is going to be here.
Okay.
You understand my point? So this place, while on the top is void. Why this place, while on the top is slab? This area, while on the top is slab. Do you understand now?
Yeah.
Now my question now is, if I'm on the first floor, this slab, is it cantilever or is not cantilever? I said it's cantilever. Why?
Cantilever.
I said it's not cantilever. Why? Now it depends. When you are designing, I can decide to span my slab anywhere I like. I can decide, while designing, I can decide to span my slab anywhere I like. What I mean by spanning is I can decide to determine how the load distribution of the slab is going to go. Now, the normal convention is if I take a section YY, if I cut this slab like this and I check it like this, what I'm going to see is going to be a cantilever. Are you following me?
Yeah.
What I mean by that is the only support that will be for this slab is going to be this beam at this side. Do you get my point? But if I decide to change the orientation of my load distribution, which I can do and nobody will question me for that. If I cut a section along this part, you can see that this slab will not be a cantilever again. It's going to be a simply supported slab. Why? Because there is a beam here and there is a beam here.
Yeah.
Do you understand my point?
I understand.
So now on site, if you are the engineer now, if you have engineered this slab to be a a simply supported slab, you don't want to lay the reinforcement. The reinforcement along this part, along horizontal axis has to be placed first before they place the one on the y-axis. Do you get my point?
Yeah.
I mean the bottom reinforcement. So that means your bottom reinforcement for your slab here, the first one that will be laid is going to be along x axis, while the one they will lay later on it is going to be on the y axis. Now, if I'm taking it as cantilever, that means this slab, the main reinforcement is going to be the top reinforcement, and it's going to be along this part. Do you understand my point?
Yes.
Because if you remember our normal manual analysis of cantilever slab, if you analyze your cantilever, the moment is going to be at the top. So if you are going to be resisting the force, you are going to be putting top bar that will be resisting the moment rather for a cantilever. While for a simply supported, the moment is going to be at the bottom. So the reinforcement at the bottom is going to be the member. Do you get my idea?
Yeah. Yeah.
I believe when we get to structural detailing, we are going to talk at length on that because it's very, very important. So let's go back to what we are doing. Okay. Now we've done this. I can say with this beam here, we have finished this area. This area, we have finished it. Now what is now left? Now this slab, we need to do something about it. Let's terminate this beam here. Let's terminate this beam here temporarily. Now, what do we have left to support? Let's pick the first floor slab. Now we have this veranda, right? We have this extension of the first floor here. We have supported this area. Then we have this small veranda here also that we need to prepare slab for. Now, how do we go about it? The pulley line, I draw my pulley line. Let me take this. Okay, the outline here, the outline here. I stop it on this beam. To take an offset, I'm taking an offset of 230. Now, what is the next thing that we have to do? Okay. I'm looking at the ground floor. The ground floor is green, right? Yes, the ground floor is green. Now we have drawn this beam here. We have a beam running all the way here. What is left? Okay, let's use this wall. Let's use this wall. It's a very nice wall. You can take it and have another beam that will go all the way. Then we take an offset to 30. Now, this is, I said that I don't like having my inner beam flushing to one side. If you are going to have it, let it be centralized on the block wall. So the offset on both sides is going to be the same thing. You get my point? Are you there? Hello? 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 I think he has network issues. Okay, let's continue.
I'm with you here.
All right, all right. So the whole of this veranda, I've decided to turn it to a slab, a cantilever slab. Then this other veranda, I will change it also to a veranda. Okay, so what do we have left? Now this area, we have not resolved it. We have not resolved this area. We have resolved this area. We have a beam that is going all the way already, which is very good. Okay, very good intersection there. Then what else? I think we are fine. We are fine with this area. This side of the slab, we are done with it. We are done with all this side. So let's concentrate on this side of the slab. Now, as we have done here on this upper part, you know, our objective now is we know we are going to need a planted column to support the roof. Now, what we need something here, a beam. We need a beam at this junction or at this junction, or we need something that can probably support a beam on the upper floor. Now, it's not a must that I draw what's it called here. It's not a must that I draw a beam in this portion. I can decide to change the orientation of the support. I have this place as a slab, but what I will do now is, I've seen something here. If I highlight my ground floor and my first floor, this junction and this junction is a common point both on the first floor and on the ground floor. So I can decide to have a column here and here, such that when I get to my roof general arrangement, I can extend a beam over them to this area and extend another beam to them over there. So that beam is just going to be a cantilever on the column here, and this beam here will be a cantilever on the column here. Do you get my illustration?
Yes.
Yeah?
Yeah, I get you.
All right. Thank you. So with this, I can say I'm done with drawing the beam layout. So what is now left is for us to be inserting our columns. Now this area, what do we have here? We have like a block wall here. Let's see how it looks on the elevation. On the elevation or the section. Let me see. We have a section that cut through this. No. Okay. I'm coming. Another of the section cut through it. So this is the front elevation. Where are we talking about? We are talking about this place. So it's just like an extension, just block wall extension. But nevertheless, since it's going all the way from the ground floor to the first floor, we are going to support it with probably a beam. Let me see exactly here. This place is a void. It's a void on the first floor. This is where I'm talking about. This place is a void on the first floor, and it's also a void on the ground floor. So the only thing we need to probably bridge, because it's impossible for them to have a block wall here on the ground floor and set it all the way to the first floor without it collapsing. So what we are going to do, we are going to introduce a beam to serve like a bracing to reduce the height of the block wall at that point. So what we are going to do now is we're going to introduce our beam here. We have set it by 230. Move it from the center. Okay, so it's at the center now. Here as well, although we have a beam here, so I can easily extend my beam to stop here. telling me to stop here. So let's close it up. Let's close this thing up. Let's close this one. And for clarification's sake, let's cross this place so we can know it's a void. Clarification's sake, let's seal this place up so we can know it's a void. Nothing is there except block wall. It's just a design. Okay. Then here also we have like a column. You can easily make this just a column that is going to go all the way up. So it's not a big deal. This is just it's a design, but we need to make it a structural column. We don't need it, but we need to make it a structural column. So with that, I can say we are done with the first floor GA as regards placing of beams. Let me move this away. 2000. So this is what we have. This is what we have at the end of the day. This is what we have at the end of the day. So let's question our GA. Is it okay? Okay, we have analyzed this place yesterday, last week. Now this place, is it okay? Okay, it's fine. Is this slab okay? It's fine. This slab also is fine. Can we eliminate this beam? If we eliminate this beam, what's the implication? What's the here from here to here? Is 5.6. From here to here is what? 5.6. So 5.6 by 5.6 slab is a two-way slab and it's not much. We can actually find a way of say, okay, if we can lay off that beam, is there anything special it's going to be carrying? Nothing so special. So we can take it down. We can take it down. We can eliminate this beam. Eliminate this beam. And leave it not to span to that other side. Okay. Do we need this beam here also? No. Yes, we need it because if you take from here to here, by the time you delete it, we are going to have the span, the effective span from here to here to be 7 point something meters, which is too long. So we can't do away with this beam. So we have to leave it like this. So is there any other thing that is left for us to do? I don't think there is any. We have created our slab void, our staircase void. Void it. Let's void it too. Okay. Let's move it and see what we have as a resultant. It's not up for this place. Let's stop here. Okay. This is what we have as our final layout without column.
Okay.
Now, if you want to start putting your columns, the only thing you need, because we are preparing the first floor layout, you need just your ground floor layout to insert your column. That's what I used to do. I'll firstly use my ground floor column, my ground floor layout to see where I will input where I will place my columns. Now, when that last week we created a grid line for column and we gave it a color yellow, right? So it's now time for you to work. Then with that, I've selected the layer for column. Then I'll create like a template. Mostly the size, when we are sizing our column, we take it square based on the size of the beam. If you are using a 225 width beam, you start with 225 by 225 column. If you are using 230 width beam, you start with 230 by 230 column. That is if that is if the structure, depending on the layout. Let me just put it that way. Depending on the layout. The reason why I said depending on the layout is there are some architects, when they are doing their architectural drawing, they will have shown you there are possible places where you can place your column. So that's like an advantage, especially if you are doing high-rise buildings. Architects most often than not, they will have specified, they will have given you options on where you are going to place your column. So in that instance, if you have the sizing, you can use the size, the prescribed size that the architect has given to you. Is a suggestion. So if you run your analysis, if the column size works with you, it's fine. But if it does not work, you have to increase it. If it overwork, you have to reduce it. You can't say because you can't say because your architect has sized one area for you to place your column, you now have to utilize the whole thing. It's not economical. You understand my point? So it's always good to optimize our design. It's part of design optimization. So you ensure that at least you have used your structural elements, you have used them to the expected capacity. You understand? So to avoid not over design in this extent. In this case, is doing a very expensive design, a design that is not economical. So now I will start with 230 by 230 column because I am using 230 by, I've assumed that all my beams that I've drawn so far, they are all 230 by 450. So what I will do is dimension 230 by 230. So it has come. So it's always good to confirm what you have done. This, yes, this is 230. Another one. Right? Yes, this 230. So I can start with this. I can start my column placement with this. I'll take this, copy it. If you're on your old snap, you can get the center. So now we start from where we started last week. Now we need a column here. But I wouldn't want my column to go off bits. So flush with the first floor, with the ground floor block. I've placed one column there. I need another column here. I will ensure my columns are sitting at the center of the beams. Is that so here? Yeah, it's so. We have placed two columns already. Then I need another column where I'm not just placing column. You know, we have already, when we are drawing our beams, we've already we've had an overview of where we are likely going to have our presumed columns. Let me just put it that way, because as the design goes on, you might decide to change the location and sizing of your columns. So I'll pick this, I'll copy this. So use it here. Okay, instead of doing it, it's better I pick it from the angle. Okay. All right. We have column here, another column here. So now, on this line now, we have how many columns? We have 4 columns. And the reason why I'm placing them at those points is because at those points, we have beams that are cantilever. And I want my cantilever to have column as its nearest support to reduce the load that will be on the beam. Do you understand my point?
I understand, but sorry, if you establish pillars at cantilever point, okay, they are more like a prop, and the pillars extends from the ground to either the beam or the slab direct. Is that not going to be more of a simply supported situation?
What I've done now, my column, they are not going to the slab. they are going to the beam,
The
because
beam.
yes, we have a beam here. We have a beam here too. Have you seen the beams?
Yeah.
Yeah. Now, I've placed them, if I get your question right, I've placed them here. Remember, I said later we might later need to plant a column at this point or at this point. To do what? To support the roof, right? So the reason why I'm placing my column at this point is having a column closer to the cantilever. It is going to reduce the load and the resulting moment from this column, from this cantilever on the beam. Do you understand?
Yeah.
Yeah. You know what cantilever does is it's going to induce more moment, because we are going to have
Reduce
more.
what?
It's going to induce more moment,
Okay, cantilever in this moment. Okay.
Yes, it's going to induce more moment, and it's going to have more shear. It has the probability of having more shear force than if you have a simply supported system or a
Okay.
continuous system. Do you get my point?
Yeah.
Have I answered your question?
Yes. Yes.
Okay, thank you. Now we've placed how many columns so far? We've placed 4 columns. We've placed one here, another one here, another one here, another one here. What's the distance of our column to column? It's important to check it. From here to here, what do you have there? We have 3.85. Okay, that's fine. The next one, from this place to this place, what do we have there? 4.2. Fine. From here to here, what do we have there? 3.825. That is fine. It's very good. You know, remember I told you the last week that it's always good that we if you are using a 230 by 450 beam, according to the deflection rule, you work with the deflection condition as stated in the code. That if you are working with a continuous system and is a rectangular section. Yeah, I'm assuming, although this is not a rectangular section, but when you are doing your sizing, it's always advisable to use your baseline of sizing to be the rectangular section. So we are having a continuous system. The length to depth ratio should not be more than 26. While if you're having a simply supported, your length to depth ratio should not be more than 20. So that was why I told you that if you have a 230 by 450 beam, you should at least ensure we make sure the effective length or the effective length of the beam is not greater than 6 meters. Is not greater than 6 meters. Because once it's greater than 6 meters, there is high possibility of having failure, even without doing any analysis or any design yet. Do you understand my point?
Yeah.
Good. So now let's move on. We have one here. We have placed one column here. We can place another column here. Do we have block wall there on the ground floor? Yes, we have block wall here. So I can place my column. I've placed my column here. If you observe all points that we have columns, we have block wall there on the ground floor. So all my columns are embedded inside the block wall. You get my point, which is one of the motives of the design, to ensure that of preparing general arrangement, we ensure that all our structural elements are as hidden as possible. We make sure they are as hidden as possible to retain the aesthetics and the function being specified in the architectural drawing. So the next one, we move, copy this. Where is the next point? Can I have it at this point? Yes, I can have it at this point, but I don't want to have it at that point, because if I put it here, please, I want you to observe what I want to do here. If I place this column that I'm holding, if I place it here, what is the implication? There is likelihood of having this other portion of, let me drop it first. I'll drop it on that place. So what this means is, if we are unable to have this beam as simply support, as probably, no, don't let me say simply support, as a continuous beam. That means this point, this beam is going to be a cantilever. It's going to be a second, it's going to be a primary beam. But I will not place it here. I'm going to move it. I'm going to move it all the way and move it here. Stop it there and delete this off. You see that? You understand what I've done?
Yeah.
Thank you. Any questions so far?
No.
No. Okay, good. Okay. I'm done with this. Let's sort out this point. As we have done at the left side corner, I will do the same here also. I will plant a column very close to my cantilever here. Then here, I will not put any column here. Now, I'm going to leave this area like this. I want you to do something for me. I want you to explain how the support system here will be. And this is what I've done here. I'm not going to put any column here.
Why is
I will
that?
not put any. Yes.
Because
If I put
I'm seeing. Yeah, where you have your cushion. Okay, just move it from there. Before the void, yeah, around that area, the extreme end of the beam there, not that particular one, I think opposite, directly adjacent, or parallel to this particular. I don't know. Your cursor is out, close to the void.
Okay, I've dropped my cursor at the void now. Is it to the right or to the left you are talking about?
Yes, to the left.
Okay, this beam?
Yes, that end there. Yeah. Why are we not having at that edge there? The
Here,
column
right?
there. Yeah.
Here, you mean this point, right?
Yes, that point.
Okay. Let's bring in our ground floor. Let's see if we have a column there, what is going to be the implication? This is the point you are talking about.
Yes.
We cannot put any column there. See our ground floor, see the highlight of our ground floor. This is where you are talking about. This place is a space on the ground floor.
Okay.
Do you understand my point? It's a space on the ground floor, it's an empty space. Now, I was even thinking you would talk about, okay, since we have this as a space, we can actually put our column here, but it's not wise if we put our column here. Or let me say it's not economical. Because if we take our length from here to here, what we have is just 5.625. Are you following me? Are you following me?
Yeah, I'm following.
Yeah, from here to here is just 5.265. Now, if I'm having 5.625 beam and I'm having two other beams on it, that means instead of having a column here, I can decide to make this 5.25 beam, 5.625 beam, a primary beam. Then these two other beams, this one, these two beams, and this beam, then this beam. You have seen the beams that I've highlighted. These two beams, they are going to be secondary beam on this beam. On this beam. The two vertical beams, they are going to be secondary beams on the primary beams, on the primary beam rather. Do you understand that?
Yeah.
Okay. So now what I've done now is I will not introduce any other column here, and I will explain why. I have a column here. My column is very close to this beam. So I can decide to make this beam at this junction a primary beam. So once it is a primary beam, it's going to be the one supporting this beam instead of having a column at this point. Do you understand?
Yeah.
You know, last week I explained that if you are doing your general arrangement, there are various ways of supporting your beam. You can either use your column to support your beam, or use another beam to support another beam. The beam that is supporting another beam is the primary beam, while the beam that is being supported is the secondary beam. So in that case, at this junction, the horizontal beam is going to be our secondary beam, while the vertical beam here is going to be our primary beam. Do you understand that? Hello, are you there?
Yeah.
All right. So I'm done with this point. I've added everything that I want to add here, and I'm done with this point. So to this level, I can say I'm done with the placement of column. So now we are moving forward. We are moving forward. Okay. Now here, I would like to place another column here. I've placed another column here. Now let me check. Can I place my column here? Very good. This is a very nice junction. So let's place our next column here. We have been there. We have a block wall there too. And utilize this block wall. Then with that, can I introduce one here? Yes, I can. There is a block wall there. So I'm moving here. So now I've supported all my beams from all the beams that are in this whole region that my cursor is moving around. We have supported them. We have supported them. Now we are moving forward. Now here now, can we have a column here as at this junction? Yes, we can. So we move our column. We copy my column from here. This point. Then here also, can I have a column here? Now, before I have my column here, can I neglect this point as I've done here? At this point, you know, I said I have primary beam and secondary beam. Can I also use this junction as that case too? You know, the more you use the primary beam and secondary beam support system, is the more you reduce the number of your column, and it is making your design more economical. Just imagine, instead of you having a column, what does a column require? The column is going to your is going to your foundation. You have to design a foundation for it. You are going to place reinforcement. You are going to place concrete inside it, and it's going to come all the way again. But if you're having a beam to beam system, it's just a normal thing. As you don't need any. You have reduced the whole cost of doing all those things I've highlighted, I've explained. Probably you have cut a lot of cost and also time, and also your design is being when it comes to serviceability, it's going to serve the purpose you are designing it for. So let me check if this from here, from the last column we have placed there to this junction, if it is not too much, we can actually notice it's not too much. It's just 5.6. So I can decide to eliminate the idea of placing my column at this point and have that column at the extreme end here. So what I will do is I will take this all the way and have it here. Do you understand my point? Are you following me? I think it's very, very busy today. All right, I'll just continue. So if you have any question, you can ask as time goes on. You can always ask your question. So the next column, I'll plant my other column here. Then what else? We are done with this area. All our beams from this area, we have this beam has been supported by these by these three columns. 1, 2, 3. Then this beam, it has support here, it has support here. This beam, yes, it has support here, but here it is having this beam, this vertical beam as its support at this junction. So here, this vertical beam is my primary beam, while this horizontal beam is my secondary beam. Next one, I will have to copy this, the last column that we are going to place on this line. It's going to be here. So we have this. So this long beam is not that long, but we start from here. We are going to do what? Where are the support? We have, where is it? Let me hold it. Just select it. Okay, this is the beam I'm talking about. How many support do we have for it? We have one column here for it. We have another column here for it. Then we have another column here for it. Then on the last note, we have another column here for it. Making like how many columns? 1, 2, 3, 4. For this alone. Wow. Can we actually do something about it? Okay, I will see to that. But it's not necessary. I think this is economic. If this from here to here is no more than 3 meters. Okay, it's 3 meters. So I will leave it. I will leave it. I was thinking of say, okay, is it possible for us to remove one out of these two and have one column at the center? Do you understand what I'm saying here?
Yeah.
Huh?
Yes, I do.
Okay, all right. And the last one, we place one here, place another beam here. This beam, I'm sorry, this column is going to serve as support for this cantilever beam here. And what I want to do here is I want to plant this beam. I want to make it a cantilever on this beam. So when you are doing, you remember when we're in when we are doing our manual analysis, there are some times that you see during our structural analysis, you see a beam that they are going to tell you, okay, this beam has a moment, probably at certain points along its span. This is a typical example of what we have in that scenario. So I'm having a support at the two ends, but towards the midspan of this beam here, I'm going to have a moment, and the moment is going to come from this beam, because what I'm planning to do now is I want to make this beam a cantilever on this beam. So when we are analyzing, when the software is analyzing this beam, we have to check properly that as this beam, do we have any extra moment at this junction? If there is none, that means our analysis is wrong. If there is, that means the analysis is right. Do you understand my point? So there is tendency of having this beam having a lot of reinforcement, despite being just, I think it should be around 3 point something meters. Yes, it's just 3.825. So on site now, all these iron benders or all these foreman, you might see a design, they'll tell you 3.6, just 3.825 meters. None can fee 40, 20. See, I know the design is not right. They don't know what you have done there. So, and as an engineer, also, you have to understand the concept of what you do. The reason why this beam might have more reinforcement is because towards the center, there is an additional moment that is going to be induced due to the beam that we have attached to it. And this beam is going to act like a cantilever to this beam. Do you understand my analogy?
Hmm.
Do you understand my analogy?
Yes.
Okay, thank you. Okay, on a last note, I have one head here that I need to support is this point. This point. What is from here to here? Length is much. Here to here is 5.65, 5.625. So it's fine. So with this, I can tell I'm done with my column placement. Except I can say, let me draw this. I said we're going to make this a structural column. It's not necessary we model it in our model. We don't have to add this. This is not doing anything. You just need to include it in our structural layout. So now, so far, let's see what we have done. We have placed, and placed. And this is what we have done so far. We have placed our beams, our columns. So let's start analyzing it. We have this first horizontal beam is going to be simply supported, and it's going to be supported by this cantilever beam and this cantilever beam. That's that. This horizontal beam also, this horizontal beam is a continuous beam that is going to have cantilever. This end is cantilever for this beam. For this beam, we have support here, we have support here. But hey, please give me a second. I need to plug my laptop. Okay, I'm sorry for the interruption. I'm back.
No problem.
Okay, now this beam, as I've said, here is going to have a support, like a pin support. Here also is going to have a support, but at this edge, it's going to serve as a support to something else. It's not going to have a support. It's having a free hand. Now, what else? This beam, how is it going to be? It has support here, but here it's going to serve as a primary beam. Here it has support, here it has support, but here it's going to act like a primary beam. So I'm taking the horizontal beams first. Now, how is this guy going to be supported? This beam, this vertical beam is going to serve as support for it. Am I audible? I think I'm.
Sir?
Please, can you hear my voice?
Yeah, I'm hearing your voice.
Thank you. Now, this beam here is going to have a support here, and the support is going to be this vertical beam here. It's going to be this vertical beam. So this vertical beam is going to serve as a primary beam for this highlighted beam here at this point. Then at this point, this highlighted beam is going to serve as primary beam for this vertical beam here. And also for this vertical beam that I'm touching currently, it's going to serve as primary beam for it too. But at this point, it has column that is going to support it. And at this end, it's going to serve as a support. That's that. This, how is it going to be supported? We have column at this end. Then at this point, we have, what's it called? We have a beam that is resting on it. So this highlighted beam at this point is going to serve as a primary beam, while this vertical beam is going to serve as, is going to be a secondary beam for it. At this junction, it has a column that is going to support it. At this end here, this highlighted beam is going to be a support. So it's having a free hand here. It's going to be like a cantilever at this end. That's that. This one is a very simple beam. Is a continuous beam with two span. It's a two-span continuous beam. But at this point also, is going to serve as a primary beam for this vertical beam.
Yeah.
Now, this beam is a simply supported beam. This beam that I've highlighted is a simply supported beam. This beam is a continuous beam that's having two span and is supported by three columns. This column, and this column. This beam is a simply supported beam, but is going to have an induced moment at this point because we are planning to fix this vertical beam on it. So when we are done with our analysis, this is like a beam that we need to cloud. This is a cloudable beam. We need to check later when we are done with our analysis to see how the software has really analyzed it. If it has analyzed this the way we have actually presumed it should be. Now, this vertical beam, how is it going to be supported? It's going to be supported here by this small cantilever that is coming from this horizontal beam. Also here is going to be supported by this cantilever beam from this column. But at this point, it's going to serve as a support for this horizontal beam. That's for that beam. Then this other beam is having three supports, is having four supports. This column, this column, this column, and this column. So we can actually say this beam is a three-span continuous beam. It has span here, span here, span here, but it has four supports.
Continuous beam, you said?
Yes, continuous beam, continuous beam. This beam, how is it going to be supported? Now, this beam, this vertical beam that I've highlighted, here at this point is going to be a primary, it's going to be a secondary beam. It's going to be supported by this horizontal beam. This horizontal beam that my cursor is going on it. And at this point, it's going to be supported by a column. And at this end, it's going to be free because it's going to serve as a primary beam. It's going to support this horizontal beam here. Now, this beam, how is it going to be supported? We have this beam here is going to serve as its first support here. So this beam, this highlighted beam at this first point is going to be a secondary beam. You understand? And at this junction is going to be a primary beam because this horizontal beam is going to rest on it. Why at this point it has its column at its support. At this end is going to have a column at its support, and at this other end is going to have a column at the support. But at this point is going to have this beam that my cursor is actually highlighting now, is going to have it as a secondary beam on it because it is this vertical beam that I've highlighted that is going to be supporting this horizontal beam. That's the support system for that beam. Now this beam, how is it going to be supported? Is a simply supported beam. It's going to be supported by this beam and it's also going to be supported by this beam. Just one span, and it's going to be supported at the two ends by beams. This beam, how is it going to be supported? The last two beams, you are going to be the one to explain how they are going to be supported to me.
Which one, sir?
So this one, I'm going to explain this, but the last two beams, you're going to be the one to explain how they are going to be supported to me. So this beam at this junction is going to be a secondary beam. Why? Because it's going to be supported by this horizontal beam. This horizontal beam is going to serve as support for it. Now going forward, at this point, it has column as its support. But at this end, it's a free beam. It's a free end. It has a free end because it's going to serve as a primary beam for this horizontal beam. So we can say this is a two-span beam, but its last end is free, is a cantilever. Now, I want you to explain this beam to me. How it's going to be supported. So I will start from the bottom. Yes. How it's going to be supported at each junction. Now, this junction, what is going to be support for this beam?
Yeah, if you are you referring to the horizontal beam?
The beam that is currently
Obviously,
highlighted.
sir?
The beam that is currently highlighted.
Okay, that's the long beam.
Yes, the long beam. At this junction, what is
Yeah,
supporting it?
it's simply supported there
It's not simply supported. It's supported by a column.
by the column. Okay.
Supported by the column. So at this junction, what is supporting it? This beam that I've highlighted.
The column also is supporting it there too.
Awesome. Thank you. At this junction, what is supporting it?
The column.
Thank you. And at this point, what is supporting it?
The column is supporting it.
So at this junction, what is happening? Can you explain what is happening at this junction to me?
Yes, at that junction is appearing as a cantilever, and
Okay.
the beams there are supporting the slab.
Okay. So it's acting as a cantilever, agreed. But what is it supporting?
The beams are the ones supporting it, the slab.
Yeah, the beam are supporting the slab. But what I want to hear, I've not heard it. As this junction that my cursor is going around, there is something going there. Which one is the primary beam? Which one is secondary beam?
The secondary beam is the horizontal beam, as it's being supported by the vertical beam, the long vertical beam there.
Okay. So this column at this end is going to be a cantilever with a punch load at the end.
Okay.
Do you understand me?
Okay, sir.
The punch load is going to come as a result of this beam that it is supporting.
Okay.
Do you understand my logic?
Yes, I understand, sir.
Thank you. Now, this last beam, I want you to explain how it's being supported to. Starting from here, what type of beam is it? Is it continuous? Is it simply supported? Is it cantilever?
It's a simply supported beam, sir.
Thank you. So how is it supported?
It's supported by the beam, the column as well as the horizontal beam there are the one holding up that beam there, sir.
No.
You get the support from that column there and the horizontal beam passing through the column to the extreme end there.
No.
Sir?
No. It's a simply supported beam, correct?
Yes, sir.
But it's supported by two beams.
Okay.
So it's actually a secondary beam to two other primary beams.
Okay.
That's what I want to hear. It's the term that I want to hear. Primary beam, secondary beam. Primary beam, that's a technical word.
Okay, sir.
Do you understand? So here at this junction, this beam is actually a primary beam to this beam. Sorry, it's actually a secondary beam to this horizontal beam.
Okay, to the horizontal beam itself.
Yes, at this point, this beam that I'm highlighting
But
at
then,
it.
sir, what I saw is I'm seeing the pillar to have his own support system there too.
Yeah, it's pillar, but it's not pillar. It's column.
Oh, column, sorry, column. The column is supporting it there.
No, the column here is not linked with this guy, with this
Okay.
with the beam we are analyzing. This
Okay.
column is linked with the beam that is supporting the beam that we are talking about.
Okay.
Do you understand?
Okay, sir.
Yeah. At this junction, at this joint rather, can you explain what is happening so you can see it? I've broadened it out.
Where, sir?
At this junction,
Yes, sir.
which one is primary, which one is secondary?
The horizontal seems to be shorter. So I'll
Okay.
take the horizontal to be secondary, sir.
The horizontal is shorter and is the secondary.
Yes, sir.
No, that was two contradicting things. The shorter, most often than not, is the primary, while the longer is the secondary.
Okay.
So in a nutshell, this beam I've highlighted is actually the secondary beam at this junction. Why the beam that I've just highlighted now is the primary beam, because it's going to be the one supporting this beam. If you draw your bending moment diagram for this beam, it's going to look like this. Circle. Something like this. Just take it like this.
Okay.
It's going to be like this for this beam. Why? Because this beam, this line, this support here is this beam here. Why this support here is this beam here. Do you understand my point?
Yes, sir.
So when we analyze, when we are done with our analysis, we expect this beam to have something like this when it comes to the bending moment diagram.
Okay.
So each of all these beams, we can actually presume how their bending moment profile is going to go with what we have currently now.
Okay.
So with this now, we are done with our first floor general arrangement. We have all our fixtures. We have the beam, we have the slabs, and we have the column. Any
Okay.
questions so far?
I think when I go through the lectures again, I'll throw my questions.
Okay.
Yes, sir. When I go through it again, I'll send it through you. I'll DM you.
Okay. No problem. No problem. I might reply late because there is time difference. So, but anyways, anytime I see your message, I will reply. I'm sorry.
Okay.
Okay. So it's always good to double check what you have done, because that's one of the things. So you might have finished everything that you have done, and you see, oh, I've done one nasty thing here. Okay, it should not become like a very big issue later. It might later become a very big that you have to start all your, what's it called, all over again. So let's check on our ground floor. Is there any blunder you have committed? Is there any column that is showing where it's not supposed to show? Okay, our column on this line, they're all embedded in the block wall. Yes. Is there anywhere you see yellow showing alone? Is there any place you see rectangular yellow showing alone? No. Everything are inside the block wall. And we have our beams properly supported. Do you understand? Okay, now what's the next thing to do? Once we are done with the first floor GA, the next thing we do is we prepare our, what's it called? Roof beam GA. Our roof beam GA should not take us much time because it's just roof. Although depending on the complexity of roof beams sometimes might even take much time than the what's it called? Than the floor GA, depending on the complexity of the beam. Now if I want to start my GA for my groove beam, how am I going to start? What I will do now is my prepare the first floor GA that I've prepared. I will take my first floor plan on it to see which of the column is going to be successful enough to go to the first floor and which one won't be successful enough to go to the first floor. Those ones that are unsuccessful, we terminate them on the ground floor. Those ones that are eligible to go up, we are going to do what to them? We are going to extend them, make them continuous. Then we see, okay, those ones that are continuous, will they be enough to serve the purpose of supporting the roof? If no, okay, where can we introduce another beam? That's where, where can we introduce another column? That's where the concept of having planted column comes into play. So those planted columns, we are not going to say, okay, can I introduce another beam on the first floor that I can plant my column on it, and there won't be any obstruction or any issue whatsoever. So now what we do next now is we take our first floor plan, we take it on top of this first floor structural GA that we have prepared. So we now see columns that cannot go. Columns that cannot go, we strike them off. That's the first thing we do. Now you can see this guy now. You can see this guy is so unfortunate, it cannot go. Why? Hello, are you there? Hello? Hello, Mr. Swell.
I'm here.
Please just
I'm
give
with
me
you.
little attention. I promise to end the lecture today exactly by 4.
Yeah.
Please.
Okay.
Because you know, GA, I can't deceive you. There is nowhere there. I don't think there is any textbook that treats GA. In fact, if you have any textbook that treats GA, you can't have a textbook that treats all GA, because GA is not something you just read inside book. It's more of imagination, and it's more of critical reasoning. You understand? So if we do it together now, I believe by the time you are doing your own, everything is going to come at ease.
Okay.
All right, thank you. All right, I said the columns that cannot go up. What I've done now is I've removed my ground floor layout. We have confirmed all the columns that we have placed, that they are well placed inside block walls on the ground floor. Then what I've done now is I removed the ground floor layout from it. Then I now place the first floor layout on it to see which of the columns we have the opportunity of extending to the first floor. Those ones that will extend, we leave them. The one that cannot extend, we strike them off. That's what we want to do now. So we want to do striking off of columns that are going to terminate on the ground floor. That's the technical implication. All right. So now let's start with this column. Can it go?
It can go.
Thank you so much. So what we do is we strike it off. I prefer, there are different ways that people use in denoting columns that terminate, but I prefer to use this strike. You know, it's cancel. That means it is stopping on
Okay,
that.
that's what that means. Canceling it out then.
Yes.
Okay.
Yes. You can
It means
some other drawings.
It exists below, but not an extension.
Yes. It exists below. It does not go beyond the floor under that level.
Okay.
You understand? Although you might have some drawing that they will not use this sign. They might use this sign. But the most important thing is when you have your general your drawing and you have signs, you should check around for the legend. So when we are done with our own structural layout too, we are going to prepare our legends to represent that. Okay, if you see anything like this, so what it means is the column terminates on that floor. Okay, if you see anything like this, so what it means is the column is planted on that floor. So it's starting from that floor. So when they are tying their beam, they should put starter bar inside that beam. That is what it means by planted beam on site. So now, can he go?
Yes, it can go.
Yes, good. This guy, can he go?
Can go too.
Okay, what of this?
It can't.
It can't. You strike it off. To be economical and wise, I would prefer to copy this. I just paste it on anyone that cannot go. Okay, we are done with that level. Here, can this beam, can this column, can it go?
It can go.
Thank you. Can this one go?
Yes, it can.
This?
It can too.
It can. What of this?
That one can't.
Can't. Can't, you strike off. Can't, you strike off. This one, can it?
Yes, it can.
No, it can't. To some architects.
It can.
It can't.
This one? That one
Yes,
can.
it can't. It can't.
It can by the door.
Yeah, there is door there. So now this is where you now come. Assuming you are doing GA now, what I used to do is this place now, I will just cloud it. You understand? I will tell the architect, please, for goodness sake, help me adjust, find way to adjust your door. If it is okay, can you help me shift this door to this point? Are you okay with it? Or help me shift it in a bit, just for me to have my, because if I tend to say, okay, let me adjust this column, fitting in with the door, it's going to create more movement on this beam, on this column, because having a column at the intersection of beams is okay, it's preferable than having it at an offset, at an eccentricity. It will not be at the center again, and the column will be subjected to unnecessary what's it called, moments. So it's going to be more of biaxial column than being an axially loaded column. If we have our column here, I believe you understand what I mean by axially loaded column.
No, I don't know. You call it what?
There are different type of we have different types of column based on the load that they are resisting. Yes. Okay. Yes. Number one, we have axially loaded column. Axially loaded columns are columns that the only load we have of them on them is just the shear force.
Okay.
We have number two, we have biaxially loaded column. Biaxially loaded column are columns that have both shear for both axial force and moment.
Okay.
And the moment is going to be as a result, is going to be from the beams, from the beam they are supporting. Like for instance, now you see this column here, this column. This column that I've highlighted is going to be by axially loaded column. Why? Because this beam, these two beams that are passing through it, that are resting on it, this beam and this beam. This beam, it has only one thing that is given to this column at this point, and that is axial load. It's not going to transfer any moment to it, because we're going to pin it at this point. But the other friend, which is this guy, this beam, is going to transfer two things to this beam, to this column. Why am I saying beam? It's going to transfer two things to this column. Number one is going to transfer at this point we are going to have shear force, which translates to axial force, and also this cantilever is going to induce certain amount of moment on this column. Do you understand? So by that we are going to have this this column as a biaxially loaded column. Which means it's going to have shear force as load, and it's also going to have moment as load.
Okay.
Do you understand my logic?
Yes.
My explanation, rather. Do you understand my explanations?
Yes, I do.
Now I want to test if you really understood what I've explained. You see this column that we took off, that is not going to go, that we terminate on the first floor. Is it axially loaded column or biaxially loaded column?
It's biaxial.
It's biaxially loaded column.
Yes, sir. Because it's meeting two separate columns, two separate beams, and it's carrying their loads two different directions.
Two different directions. Okay, I'm coming now. I want to give another example. I'm not yet satisfied with this one.
Sir?
I'm not yet satisfied with this explanation, because this column analytically it should be an axially loaded column.
Why ACL? When we have this column here, the column from that other one we come to that point, we have a beam spanning a long beam from that end to the extreme end of the floor plan there. Then you have the vertical beam as well.
Yes, but that's not the explanation to it. The explanation to it is analytically. I'm not, there is a big difference between analytical and how structure is going to behave. Structural behavior, structural analysis sometimes does not really explain the real life behavior of structure, but it gives us just an idea of how it's going to behave. Analytically, if you are going to analyze this beam, you are going to say this beam is simply supported. What that means is you are going to say is pin, like what I drew here the other time.
Yeah.
1 minute, please. Okay. Now this bending moment diagram. Are you with me?
I'm with you.
Yeah, this bending moment diagram is a typical bending moment diagram of a simply supported beam. And that is what we have as per this beam. This beam, this column here that we are terminating is this line that I've drawn here. And this other beam that is serving as primary beam to this beam that we call secondary beam at this junction is this line that I've drawn here. Now, the moment that is going to be induced inside this beam is going to be this. The maximum moment is going to be at this point. Now, if you draw the shear force diagram, how would the shear force diagram look like? Shear force diagram is going to look like this.
Yeah.
This is how the shear force diagram is going to look like. What the shear force diagram is telling you, I said this beam, this column is going to have a shear force. It's going to be axially loaded. How do you know the axial load that is going to go on this column? The axial load is the value of the shear force that you have here. Is the shear force here that is going to translate to the axial force that you are going to use when you are doing it. That's if you are doing your manual analysis. Although since we are using software, the software is going to do everything for us. So is this shear force diagram the value of the shear force here that is going to translate to your axial load at this junction? Are you following me?
Yeah.
Also, I said this beam is a primary beam. If you're analyzing it, there is going to be need to add a point load at this point. How do you know the value of the point load that will be at this point? The value is going to be the value of the shear force here at this junction. If you're having 50 kilonewton, it is that 50 kilonewton that you're going to put when you're analyzing this beam, when you're analyzing this vertical beam, and you're going to put as your point load on it. Are you following me?
Yeah.
Okay, that's fine. So now, if you observe this beam, since we have taken it to be pin, what pin support means is the only thing I want you, this beam, to do to this column is please just transfer force alone. Don't take any moment to it. That is why at this point and at this point, we have our moment diagram to be 0.
Okay.
Do you understand my point?
Yeah.
Yeah. So analytically, this beam the only effect, the only load that is going to transfer to this column is going to be shear force, and that shear force is going to be what we refer to as axial load. Do you understand my point? Okay. Now, how do I say it? In real life, there is still going to be a small amount of moment, very minute amount of moment that will be transferred from that beam to that column or to the other beam also that is supporting it. So in real life, the behavior of this simply supported beam is going to be like this. I shouldn't. Okay, let me do something. So this is the real life picture of what we are going to have analytically, but this is the theoretical behavior that we are going to have. Do you understand? So this small moment, even if it is let me say 3 kilonewton meter or 5 kilonewton, as small as it is, this moment is going to be transferred to that column. So that's why I'm being conscious when I'm using my word. I will say analytically, this column is going to be axially loaded column with respect to this beam. But with respect to this beam, because if you draw the bending moment diagram of this beam, it's not going to be like this. It's going to be, this one is going to be long, but I'll just try as much as possible to sketch it. Because these are fundamentals. These are some of the things that I mentioned in the objective of this program. That we are not just going to be doing structural design. We are going to see how manual calculation is being transferred into reality. You understand? And how we expect it to be when we are done with modeling and analysis on our software. So if our software is giving us anything that is different from what we are known, we know, oh, there is an error in this case. In that case, we will not say a software that is using us. We are the ones using the software. Do you understand?
Yeah.
So now I want to try and sketch how this oh my God, how do I do it? Let me try and see if I can use spine. Use spine. Okay. Okay. Make sure I sketch this thing properly. Come on now. That's wrong. Okay. Oof. Okay.
I'm making use of polyline, right?
No, I'm using Spline.
Okay, spline.
Spline. Yes. Yes.
Okay.
No. Okay. Just for explanation's sake, this is how the bending moment of this beam is going to. How many support does it have? We have this column 1, this column 2, this column 3, and this last column 4. Is that the first column? This. The first column this, the second column this, the third, and the last. That's what we have. Now, the column we are referring to that we are trying to analyze is this beam, and that's like the second to the last. And this beam. I'm sorry, this column here. You can see it has what's it called here? Moment. That moment, certain magnitude of moment here, which will be significant. So with respect to this vertical beam, on this beam is going to have moment. So we can say with respect to the vertical beam, this beam is going to be biaxial.
Okay.
Because it's going to have both the shear force. If I sketch the shear force of this, let me just try and sketch it. Make everything complete. So if I sketch my shear force diagram for this beam, it's going to look like this. Are you with me?
Yeah, I am.
Yes. So the bending profile should look like this, while the shear force profile should look like this. Now, this is the column we are talking about. The column is going to have both moment and what? And shear force. So in that case, it's going to be what? Biaxially loaded column. Do you understand?
Yeah.
Okay. While this column here, this column analytically, the moment here on it is 0, but it has shear force. So it's going to be what? Axially loaded column. So generally, this column we can say is a biaxially loaded column. Do you understand?
Yeah.
You understand my analysis now?
I understand.
Yeah, thank you. So now what we are doing before was we are trying to strike out beams, columns that will go and those that will not go. I'm sure this is the only aspect that might take us much time. By the time we start the modeling, we are going to speed up. And I don't want us to rush much here because this is where the bulk of the work is.
Okay.
Right. Okay, yeah, okay. Can this go?
Yes, it can.
It can?
Okay, no, it can't. It can't.
Yeah, thank you. Thank you so much.
It can.
Thank you for that. Back it off. It can go. Okay, let me highlight again. Which other yellow? Is there any other one that cannot go?
Let me see.
Okay, we are starting from down. I'll be going up now. Are you there? Have you checked here?
Yeah. Yeah.
Okay. This point, what do we say we are going to do?
You say you ask the architect to change the positioning of the door.
Okay, thank you. So we have asked our architect, and he's a very humble person. So he has agreed to shift the door for us.
Okay.
So let's just assume he has agreed. But there are some architects that are so adamant, and in the first place, that's what they are going to tell you, that they cannot shift it. But if you explain
Wow.
to them, tell them the implication, you understand.
Yeah.
Some of them they succumb. But if they don't, you should tell them, oh, Oga, this thing, if I do this thing, it's going to increase the cost of construction, and these are the implication on it. It might lead to buying of more reinforcements. It might lead to more time in the construction. If they tell you, okay, I don't care, then you go on by shifting and see how the structure is going to behave. But if it is the economical, I know they also take into cognizance the cost aspect of construction too. So they will accept and shift it. But in some occasions, they will say, oh, that is what is making that house special, so I will not change it. So now we have talked with our own architect. He's the humble person, so he has agreed to shift it. So I'm going to delete the cloud. Okay. So now which other one? I'm going up. Are you with me?
Yeah, I'm with you.
We have 10 more minutes. In 10 minutes, I'll round up. So I think we've cancelled everything. All the what's it called? All the columns that cannot go with us.
Yeah.
We take this ground floor, we take it on, we take it away. At the first floor, 50,000. Good. So now what I like doing is, again, I usually create another layer for my planted columns, because there are
Okay.
some instances that you might want to edit something and you want to take up just only the columns that are planted, or you just want to do something on them, or you want to assign one symbol to them, or you want to do whatsoever. So it's always good as an engineer we work with our layer properties.
Okay.
The importance is far more beyond what I can really explain. So now I'll create another one. I will tag it planted, or let me say first floor planted column. So let me shorten it. Planted column. Writing first floor in full. I'm actually shorten it first floor. Then we can give it, let's say, should we give it yellow? We can give it any color of our choice. But for different, give them different meaning. Let me use red. Oh, red is for the slab, Abby. Let me give it green. Ah, green. We've used green before. Let me give it this. Okay. So now, the next thing we want to do now is we take out the columns. I would prefer to take this up, this up by, let's say, 50,000 too. Then I copy it back. Okay. So this I can delete. So what I'm doing is not to, don't let me delete, don't let me write them off. So now I'll take this back. 50,000. Then I delete off all the beams and columns that cannot work with this floor layout. This I take it off. The other one, these two I take it off. Does it go all the way down? Yes, it goes all the way down. So let me just reduce it to stop here. These two. 7 minutes. Okay. These two. All right. Which other one? Which other column did we say is not going? This guy too, Abby. So let's take it off. Something I want us to note here. Yes, where? Okay, yeah. Which other one? These guys too. They cannot go. I see one feature here. What is this? Let's see. What is this on the first floor? Oh, this thing starts from the ground floor, right?
Yeah.
They said, yeah. But okay, it's just design. It's not structural. It's just design. They can use anything, any material to do this. This is it on the ground floor. It's not a big deal. This is it on the terrace. Just on a design. This is it. You can see it's not even reaching the top of the roof. It does not even reach the top of the roof. It's pergola. It's pergola. Now, sometimes this feature, sometimes the architect might say, oh, I want this thing to be steel. So if you want it to be steel, that means on the roof, we need to prepare a beam at this point. So they can weld or screw or whatever support they want to give to this thing. So they can install it here. You understand my point? When we get to the roof, we talk more about that feature. Thank God I saw that. Okay. Which other one? Which other one? Which other column? We took off. None. Okay. What's now left? So what is left now is we take okay. Rectangle. So what we use as a baseline for the planted column 230, like we did for the first one. So this is what we are going to be using. This is the color and the what's it called? The sample of the planted column we are going to be using for our layout. Now I will stop here because we cannot finish the planted columns, and that will be the last aspect. So we are going to continue from here in our next class.
Okay.
What we have done so far, just a brief recap, we're able to conclude on our beam placements, and we're able to place our columns, and we're able to analyze them, at least to a certain extent, that which one are going to be which beam is going to be primary, which one is going to be secondary, which column is supporting which column, which beam is supporting which beam, then which column is supporting which beam, then how are they going to be connected, then we explain that. Then we move to how some of the beams is going to behave in terms of being the load they are going to transfer to the columns. If they are going to have moment, or they are going to have moment effect, or shear force effect, or axial force effect, as the case may be, on their support, be it column or beam. That was what led us to this diagram that we drew. So later we're able to strike off columns that are going to terminate on the first floor. So that means those columns are not going to extend beyond first floor. Then on the last note, we prepared a layout property for our planted column. So by God's grace, that will be on Saturday. On Saturday, same time, 1 to 3. So we are going to continue from here.
Okay.
So it's my pleasure to have you in this class.
All right, thank you, sir.
So glad to have you, and thank you
All right,
for following. If you have any
all right,
question,
sir.
as I've said earlier, you can
Um,
come to, you know how we communicate.
yes, sir.
Yeah. Thank you so much.
Okay. All right, welcome.
Have a nice day.
Thank you, sir.